And welcome back. As we continue our work with classes, we're going to take a moment to actually pause to look at local variables and blocks and actually put some context to some of the things that we've been doing. So let's start first with local variables. Here's a simplified version of our definition of the method read input. Public void read input, scanner keyboard equals new scanner system in, system out print line, enter month, day, year. System out print line, do not use a comma. We get month, day, and year. All right, pretty simple. It just doesn't have all the if statements in here to check for valid input. Well, if you notice in here, this method includes a declaration of the variable keyboard. Now, a variable that's declared within a method is what is known as a local variable. So, why do we call it a local variable, and what is their purpose? Well, let's start with that first part. Why is it a local variable? Well, the variable inside of a method is technically confined in scope to that method definition. That means if I try to access it outside of that method, we're going to encounter an error as if it hasn't even been defined. It doesn't know what it is. So, for example, we have two methods with both local variables keyboard. The program would actually treat them as two distinct variables, even though they share the same name. Any change to one variable actually will not affect the other because, again, they only exist technically within the scope of that method. So let's look at this with an example of something that we might already know. So declaring variables in a for statement. If you recall, we can declare a variable or multiple variables within the initialization of a for loop. So for example, in sum equals 0, for int n equals 1, notice we're initializing it here in the header, n is less than 10, n plus plus, sum equals sum plus n. If we declare n in this manner, it is only local to that loop, which means if I'm going to have it exist outside there, then we're going to run into issues because it doesn't exist outside that for loop. Therefore, we tend to be careful when we're declaring variables inside of a for loop, except in very simple cases that have no potential for confusion. If there's any kind of chance that that variable is going to be used elsewhere, then we'll make sure we sanitize it so that it exists outside of the loop. But if it's something, for example, hey, we're just going to iterate through this and afterwards I don't care what that variable is, which happens more often than you might think, then we can declare it in the manner we see here. But let's bring it back to our conversation about methods here and introduce this new thing known as a static variable. If you recall, in the main method that we are familiar with, you'll see in like every main Java program we do, other than a couple of the classes we've started doing, you will see the term main. And this in itself is actually a very special method definition. It's what Java uses to identify as the program that's actually going to execute the code. Now, any variables that are declared inside of main are, of course, local to that method because, again, main is simply just another method, another function that exists in your code. Now, if a variable is declared in the main, happens to have the same name as another method, again, just like we said, they're going to be treated as two different variables. Therefore, up to this point, all the variables we've encountered have technically been local variables or instance variables of that main method. Now, there's something else we have to discuss, which is that of a global variable. Now, many programming languages contain another type of variables known as global variables, whose meaning is confined only to the program. This means that although the variable exists, not just as a method class, but uniquely throughout the entire program. And while we haven't seen this, it does something that does happen, but not in Java. Java does not use global variables, so this is something you don't have to worry about. However, if you go and work in another language, you might encounter it. And the last thing I want to touch base on is blocks. Often you'll hear the term block and compound statement used in programming. While they can mean the same thing, a list of statements that are inside of our curly brackets, they do tend to have some different meanings based on the context. For example, if we declare a variable within a block, well, the variable is local to that block. This means that after that block ends, the variable is no longer accessible. Note, in Java, you cannot have two variables with the same name inside of a single method definition. Local variables can sometimes create problems inside of blocks, and therefore it's easier to declare the variables outside that block. This allows you to use the variable both inside and outside the block. And sometimes when we do this, we're going to have, remember we talked about, I just mentioned static. If we look at our method main, it has that static modifier, and we may have to do that with our variables as well if that ends up being the case. Now there, of course, are things that are going to be a little bit more to touch base on with static, and we'll talk about that a little bit more as we get into it. these are just different things to think about as we pick apart these different approaches to programming. Now over here in Eclipse, I went ahead and created a variable demo, and I, of course, left some errors in here on purpose because I want you to see just what I mean when I start talking about local variables. So in here I have my main method. This is just one class here. Notice there's no secondary class for us to have to worry about at this point. But I have one class, but with two methods. I have my main method, which of course has the static modifier, and I have another static method called calculate average. And it's of course just going to calculate the average of some numbers I feed into it. And you notice in here I have declared the scanner up here, but notice it's not in my main. It is over here in this calculate average method. Which means if I were, for example, try and do that KB, you notice we immediately get an error. It doesn't know what this is. Even if I say, hey, int num equals KB dot, and notice nothing comes up. We don't get any methods here. Even if I try just to force it, it doesn't know what it is because scanner exists only in the context of this method. Similarly, you can see I have a variable called counter up here, but notice down here it's giving me an error because, again, it doesn't know what counter is. Now, if I add a counter in here, one thing you'll notice, if I put it in here, and I need, of course, to give it a type, so I have to tell you what type, so it's just an integer. I can put it as 0, and you'll notice that there's no conflict. It's not complaining that this variable already exists, because, again, remember, this is a local variable to the main method. This is a variable that's local to the calculate average method. All right, now we do, of course, have another error down here. We can see it says return total divided by counter. And if we look here, what is that reasoning? We, of course, can say, hey, all right, let's see. It says unreachable code. All right, so that's because right now I didn't have actually set up anything for this loop to actually exit. So we want this to have a condition here that's going to let this actually break out. So let's just, of course, say if the user enters in a negative number. So let's just say if num to be added is less than 0. We're going to break out of this loop. All right, and then of course we'll fix that. So this, I'm just going to add a note here to our prompt here that says enter a negative to stop. All right, and now if you look, how do we call this? Well, we have a print line statement up here, and it says the average is calculate average. And the reason why I point this out is because we have this static modifier here. And that static modifier, again, we're going to talk about this more later on, but if I wanted to eliminate this double counter that I have going on here, I could, of course, just put that int outside of here. And this is what we were talking about when we were saying putting a variable outside of a method here. And then now it is a variable that exists not local to this method. So if I comment these out, all right, now, of course, it's saying, oh, I'm getting some errors here, getting some errors. Why is it getting some errors? Well, it says it because it's making a static reference. And this is something that, again, we're going to have to approach later on. But for now, if you don't know how to do this, I just want to show you that this exists. I'm not worried about this being here. In fact, I'm just going to actually take this back out because it's beyond the scope of what we're doing. I just want to show you that that is something that we can do here. All right, but I wanted to show that, of course, we have a variable local to the main method. Here we have variables that are local to this other method. Now if we go ahead and just run our code. All right, so let's go ahead and enter some numbers. How about 5, 4, 9, 15, 7, and we'll do -1. That should stop our list. Hit enter, and get the average is 0.0. Oh, why do we get 0.0? Well, let's just take a look. Oh, we have this variable called total. Notice we never actually did anything with total. So we need to make sure that we actually include that in this number to be added. So total should then equal total plus num to be added. So gotta make sure we include that in there. And now if we rerun it, we should get a working program. So 5, 7, 4, 15, and do -1. You get the average of 6.2. There we go. And of course, that's just a quick demonstration of the local variables versus the other types of variables we're going to get used to working with. Obviously, we're going to get used to working with class variables, as we've seen with our date class. And these are things that we have to, of course, be used to handling in Java and knowing their scope, because if we try to use a variable that's outside of the scope, as we saw with counter, for example, when I first loaded this, we had some errors, and then our program wouldn't execute. So these are things, of course, that we have to work through and be ready to adapt to handle appropriately in our programming.